Hello grade 9s, this is the second half of this week's lessons. So we're staying with lines, and this time we're introducing what's called linear systems. And anytime there's a system, that just means there's more than one line. And the solution to linear systems are essentially, where do the lines cross? So that point where the lines cross is the solution to the linear system. And we're going to get into a couple examples here. So let's start off with Mark borrows $600 from his parents in order to purchase a drum set. Every month thereafter, he pays them $50 until the debt is paid back. Write an equation to model the amount of money he owes his parents, M, in terms of the number of months that have gone by. So we're going to start with that solution. So to begin, we have an equation to write. Now, M is the amount of money he owes his parents. So M is equal to, now we like to keep it as slope and intercept form, slope y-intercept form. So the slope is how much it's changing each month, the rate of change. And it says he pays them $50 until the debt is paid back. $50 every month until the debt is paid back. So they want month in the letter T. So I'm going to go T here. And my payment back to them, if I'm Mark and I'm paying $50, that's not a good thing. I'm losing money. It's negative. So negative 50 times the T. So M equals negative 50T. And you still have the y-intercept, which is how much you owe at time 0. So how much did Mark owe at the very beginning? Well, his parents, he owed need new markers. M equals negative 50T plus 600, where 600 is the amount of debt he started with, and he's reducing it by $50 each month. Now, the second part says use a table of values to graph the relationship between the amount of the debt remaining after T months. So I'm just going to make a quick T chart here to show you table of values. So it's going to start at 0 months, 1 month, 2 months, 3 months, 4 months. This is T and M. T and M. The T is the months, the M is the amount he owes. So at 0 months, he owed $600. So 0, 600. And then it reduces by 50 because he pays back $50. So 550, 500, 450, 400. So he just reduces by 50 each month. Now, it asks you to graph the relationship. So I'm just going to make a quick graph here. Not in great detail, but this is T, this is M, okay? So T and M, put our lines, and we're going to go up by about 100 each time. So there's 100, 200, 300, 400, 500, 600, and go by months. 1 month, 2 month, 3 month, 4 month, 5 month, 6 month. So there we go. And each month we're going down by 50. So remember, this is 600 up here. The dots are hundreds. So 1, 2, 3, 4, 5, 600. It's going to start there at 600. 1 month later, it's going to drop by half of 100, 50. So around there, 50. So now we have the line. Of course, it'd be ideal if we had a ruler and if we had grid paper. We don't have that. Maybe you have that, it'd be great. But if you don't, the best you can do is kind of estimate like I have done here. So try to get that. But that's the visual it looks like. It's got a negative slope, right? Negative 50, negative slope. Starts at a y-intercept of 600. Between those two details, you kind of got the most important stuff. The last part, is this an example of partial or direct variation? Direct variation goes through 0, 0. That graph does not go through 0, 0. 0, 0 is down here. That's 0, 0 right there. This is partial variation because it does not start through 0, 0. All right, there's the first question. Second question is, well, it's a system of linear equations refers to a set of two or more linear relations between the same two variables. So two lines, essentially. You have two lines. A system of linear equations is two or more lines. The solution refers to the point at which the two lines cross, known as the point of intersection. In grade 9, you're responsible for graphing and then seeing where it actually intersects by basically looking at your graph. That's your job in grade 9. In grade 10, you're going to do the algebraic version, where you look at the equations and you isolate and solve through the equations, and then you can figure out point of intersection. You're not responsible for that in grade 9, so I'm just going to show you again graphing, and then where the point of intersection is, which is just a visual of where the point of intersection is. So the two lines we have are y equals negative 2x plus 5. So y equals negative 2x plus 5, and then y equals 2/3 x plus 3. So two different lines. We've got a y-intercept of 5. We've got a y-intercept of 3. One's going up, one's going down. So let's get going. Easiest way to do this, when you have slope, you first set up your graph. You got your x-axis, you got your y-axis. And we need to go, y has to get up to 5. All right, so let's go by ones. 1, 2, 3, 4, 5, 6, 7. So there's my y's up by ones, my x's. We can go by ones as well. Let's do that. 1, 2, 3, 4, 5, 6. Now, I'm just going by ones and by ones. X and Y's are by ones. My first equation, y equals negative 2x plus 5. It's in slope-intercept form, so I'm going to start at my intercept. My intercept is, well, y equals negative 2x. That's the slope. The y-intercept is plus 5. So up to 5. 1, 2, 3, 4, 5. Put a dot. Now I'm going to go over 1 and down 2 because my slope is negative 2. So I'm going to go over 1 and down 2. Over 1 and down 2. Okay, anytime I have 2 dots on the line, I have the line. I don't need 3, I just did 3 for fun, but there's my line. Now the second one is plus 3 as a y-intercept, so 1, 2, 3, it's a plus 3 right there. And then it has a slope of positive 2/3. That means rise of 2, run of 3. So I'm going to go rise of 2, run of 3. Okay, there's my second line. Point of intersection is right there. Right in that vicinity. And we would be able to estimate a number. If you had grid paper, you could get more accurate. And obviously, the more accurate you get, the better the answer. but it's an estimate. Graphing is always going to be imperfect. It's your trying to get as close as possible to the point, and it looks like it's about, so we're at, looks like 3.5 on the Y and a value of about 1.25. So 1.25 and then 3.5. So 1.25, 3.5, or 3.5. And that's the solution for that one. So anytime you have two lines, a system of linear equations, all you're going to do is graph them, and then you are looking to see where they intersect. And that's your solution. So one more question here before I send you guys off. It's Lindsay is getting married this summer and is trying to pick a banquet hall to host the reception. A local golf course charges $1,600 to rent plus $30 every guest. The other choice is a hall that does not have a rental fee, but they charge $50 every guest. So one's $30, one's $50. But the one that's $30 has a $1,600 charge to rent the hall. Write an equation that shows the cost in terms of the number of guests for each of the choices. So I'm just going to flip this around and show you that.